Hello everybody, welcome into another lesson. So today we are going to talk about angles of polygons. So first, let's start out with what polygons are. What are polygons even? Polygons are closed figures. A polygon literally translates into many angles. Poly meaning many, gon meaning angle. So gons is angles, many angles. A polygon, simply put, is a closed figure that has straight sides. The sides each consist of line segments for a polygon. So these first three are all examples of polygons because they have straight line segments that are figures. So you got this one here, and this one here. Then the bottom three are examples of not polygons. The first one is because one of the sides curves inside of the figure and it loops around inside of the figure, then comes out. To be a polygon, the sides can't overlap. They may meet, but the sides can't overlap like it does in the first one. The sides overlap inside of this figure here, so that's not a polygon. This figure here's not a polygon for the fact that it has a curve down at the bottom. There's a curve on it. So a polygon cannot have a curve. And then the last one, that's not a polygon because it's not even a closed figure. So we definitely can't consider that a polygon. Now, when we get into polygons, there are two types. You have first what is called a convex polygon, which is really what we're going to deal with here throughout this course, are convex polygons. So a convex polygon is one such that no line contains a side of the interior of the polygon. So for example, a rectangle, right? None of these sides here contain anywhere in the interior. Or a triangle. A triangle is a convex polygon. Or we have this pentagon here. Again, none of these sides contain any point on the interior of the polygon. These would be considered convex polygons. So in this course, we're only going to deal with convex polygons, but it is my duty to show you at least one example of a non-convex polygon. So what is a non-convex polygon? It's a polygon still, but at least one of the sides, if not more, contain a point in the interior of the polygon, such as, let's say something like this. Let's say we had something like this here. You have both of these sides here on the right, they curve inward towards the inside of the polygon, right? They contain points inside of the polygon. That would be considered a non-convex polygon, kind of like the flag of the state of Ohio. Those of you that live in Ohio like me, our flag is not a convex polygon, it's a non-convex polygon. But that's really it for non-convex polygons. Now, when it comes to polygons, we classify them, we name them by their number of sides. So I'm going to set up a column here for number of sides, and then on the right side will be the name of said polygon. So the lowest amount of sides you could have to have a polygon is 3. There is no two-sided or one-sided polygon. It just doesn't work. But 3 sides, we should know this one. It's a triangle. 3 sides would be a triangle. Now if we had 4 sides, some of you are going to go right to square or rectangle. Could be, but the official name is a quadrilateral. That's the official name for a 4-sided figure. Quadra meaning 4, lateral side. And the thing is, quadrilaterals come in all shapes and forms. They can be a rectangle, they can be a square, they can be a rhombus, they can be a parallelogram, they could be a trapezoid, they could be a kite, or they could be some other irregular quadrilateral. So that's why we can't just name one of them. There's a variety of them. And we have a whole set of lessons coming up on quadrilaterals not too far down the road. Alright, if it's got 5 sides, it's called a pentagon. Again, gon means angle, pent means 5. So, also something here about polygons in general. It's true that the number of sides that you have for that polygon, you're going to have the exact same number of interior angles. And for that matter, exterior angles too. I mean, you will have them for exterior angles also. But that's a little cheat for you. If you ever want to figure out how many sides and angles, they're going to be the exact same as the number of sides you have. If it's 6-sided, it's called a hexagon. So hex means 6, gon angle, so it's got 6 sides. 7 is called a heptagon. So a 7-sided figure is a heptagon. Let me extend this line a little bit. If it's got 8 sides, it's called an octagon. Oct meaning 8. If it's got 9 sides, it's called a nonagon. A nonagon. Non meaning 9, so it's a nonagon. If it's got 10 sides, it's called a decagon. Dec meaning 10. And then n sides, so any more than 10 sides, it's called an n-gon. So in other words, if this had 11 sides, it would be an 11-gon. If it had 100 sides, it'd be a 100-gon. Actually, if it had 100 sides, it would also be called a centagon. It actually does have a name. And each of these numbers beyond 10, they're based in Latin heavily and Greek. So you could find the names that way, but in modern day math, if it has more than 10 sides, we just call it an 11-gon, a 12-gon, a 13-gon, a 50-gon, what have you. So that's a brief overview of what they're called based on the number of sides they have, which again, the number of sides is the number of angles it also has. So that's something good to know. Okay, let's move on. We have our first theorem here. There's really only 2 theorems today, and we're not going to prove them, we're just going to give them to you. So, this one states that the sum of the interior angles of a polygon actually, can't just say polygon, it's got to be a convex polygon. Of a convex polygon with n sides is n minus 2 times 180 degrees. Okay, so let's talk about that. The sum of the interior angles of a convex polygon with n sides is going to be the quantity of n minus 2 times 180 degrees. So, to find the sum of your interior angles, you take the number of sides it has, subtract 2 from it. Once you've done that, you multiply what you got there times 180 degrees. So, let's proceed to a triangle, for example. We know a triangle has 3 sides, right? So that's going to be 3 minus 2, because it's got 3 sides minus 2 times 180 degrees, which would just simply be 1 times 180 degrees, which we know would just be 180 degrees. So a triangle, the sum of the interior angles is 180 degrees, which we established that in yesterday's lesson. Well, now you see where we got that from this theorem right here. So, what if, I'll humor you here, what if we do a quadrilateral? Let's do a quadrilateral. So a quadrilateral has 4 sides, so it's going to be 4 minus 2 times 180 degrees, which would simply be equal to 2 times 180 degrees, which would be 360 degrees. So the sum of the interior angles of a quadrilateral then would be 360 degrees by this formula. I'll do one more with this. What if we had a 12-gon? What if we do a 12-gon? So it's telling us we have 12 sides, so that's going to be 12 minus 2 times that 180 degrees, which would then turn into 10 times 180 degrees, which then means it would be 1,800 degrees or 1,800 degrees for the sum of the interior angles of this 12-gon. So it's a pretty simple formula. That's the grand sum of your interior angles for each of those. Okay. I have one more theorem here today. Let's see what that one says. This theorem is the sum of the measures of the exterior angles of any convex polygon, one at each vertex, is 360 degrees. So now we're talking about exterior angles. This theorem tells us that the sum of the measures of the exterior angles of any convex... I spelled it polyon again. Dang it, I don't know what it is with me doing that today. I keep skipping the G. Good grief. That's more like it. So the sum of the measures of the exterior angles of any convex polygon, one at each vertex, is 360 degrees. So it doesn't matter how many sides it has, the sum of the exterior angles will always be 360 degrees. For those of you that remember, the measure of a circle is 360 degrees. Very interesting, which when we get into circles and talking about that, there's some theories about that. That there's constantly, though we don't see it, there's always a circle that's circumscribed about a polygon, which we'll talk about that later on down the line in the course. And this is something you can all research on your own. There's no definitive answer, but it's a very interesting thing to ponder. Based on this, and if you ever sit down on a computer and just pull up, what does a 12-gon look like? What does a 50-gon look like? What does a 100-gon look like? If you notice, the more sides a polygon starts to have, it starts to look more and more like a circle. So some research would be, for your own curiosity, would be, is a circle truly a shape with no sides? Or is it a polygon with infinite sides? That really makes you wonder. There's research that can go both ways. There's no definitive answer, and that's not one I can answer, unfortunately, but it's interesting if you think about it. But let's just look at a triangle here real quick, okay? I'll draw some lines out here on a triangle. Yada, yada, yada. Alright, so we have an exterior angle here. Let's say the exterior angle worked out to be 120. This one was 120. And then this one was 120. Assuming this was an equilateral triangle, and which would also mean it's equiangular, then all your exterior angles would be 120. You add up these 320s, you'll get 360. Or heck, let's say, just for giggles here, why don't we just say one of these is 95 degrees, right? This one's 100 degrees. So now we have 195. This one here then would have to be 165. But whatever your exterior angles are, you add all these up, you're going to come up with 360 every time. Let me demonstrate with the quadrilateral. I think that would be a very good demonstration. What if I let's draw a rectangle, just for the heck of it. I'll draw a rectangle, because why not? Let me extend the lines out here, extend the lines out here. We can extend it here. Extend it here, extend it here. Extend it here, extend it here, and extend it here. Alright. Well, yeah, that's probably not accurate. You can extend it one way or another with exterior angles. You extend the line one way or another, you don't extend it in two directions. So let's say right here this angle is 90. Well, this angle is also 90. This is a 90-degree angle. This is a 90-degree angle, right? Exterior angles, you have four 90-degree angles. Well, 4 times 90 is 360. It wouldn't matter with how many sides I did it. The bottom line is, the sum of your exterior angles will always be 360. Alright. let's talk about regular polygons. Let's talk, well, first, let's see here. Then let's draw the tick marks around this one. Of course, we still have a convex polygon, because that's all we're dealing with. We don't know if this one's equiangular. We sure know if this one's equilateral. This one is an equilateral polygon. Okay. Now this one clearly this one here is an equiangular polygon. So remember yesterday when we talked about triangles? With triangles, and only with triangles, is and this is true in all cases, and with all triangles that are equilateral. Every single equilateral triangle is also equiangular based on that corollary we learned yesterday about triangles. But with polygons in general, once you get to 4 sides and more, like quadrilaterals, it depends which type you're talking about. If it's a square, then that's really the only one, quite honestly. That's the only quadrilateral that's both equiangular and equilateral. The other ones, all other polygons besides that, once you get above triangles, just because it's equilateral does not mean it's equiangular, and vice versa. Like you can clearly see here, on this one you would have an acute angle and an obtuse angle. Right here, clearly it's not equiangular, it's just equilateral. This here, yeah, the angles may all be congruent, but clearly you see some sides are longer than the other, so clearly that's not equilateral. Well, good news is there is such a thing as polygons that have both qualifications. Those are called regular polygons. So, regular polygons are such that they are both equiangular and equilateral. So, let's look at an example here of one. Okay, so let's see. This angle's 120 degrees, this angle's 120 degrees, this angle's 120 degrees, this angle appears 120 degrees, this angle appears 120 degrees, and this angle right here is 120 degrees. Clearly we see it's equiangular, and the side lengths are all the same. These are all congruent sides, so it's both equilateral and equiangular. This qualifies this as a regular polygon, and it's got 6 sides. We would classify this particular shape as a regular hexagon. So this one here is a regular hexagon. So again, if a particular polygon meets both qualifications of having it being equilateral and equiangular, it is a regular polygon. Okay. So, for today's exercises, we are going to assume that all the polygons we're about to cover today are regular. So that's going to make our lives a lot easier for the next 1, 2, 3, 4, 5, 6, 7 exercises. Okay? So, let's see here. 9 sides, right? This polygon has 9 sides. So in other words, it's a nonagon. It's got 9 sides. What we need to figure out is the measure of each exterior angle and the measure of each interior angle. I think it's going to be best if we first start out with each interior angle. So remember this formula here for finding the sum of the interior angles of a polygon. That's going to be n minus 2 times 180 degrees, right? That's the formula for finding the sum of the interior angles of a polygon. This particular polygon here has 9 sides, which tells us then, first thing you want to do to solve for the interior angles, which, let me put that up here. Interior angles, okay. Take your formula, the n minus 2, so that'd be your 9 minus 2 times 180 degrees, which is going to be equal to 7 times 180 degrees, which then is going to, well, let me take the calculator for that. I honestly don't have a clue. I really don't have a clue what that is. In fact, let me get my calculator real quick from off the charger. I was getting my phone off the charger. That's my calculator. So 7 times 180 comes to 1,260. So we got 1,260 degrees for, that's the sum of the interior angles, okay? However, we're being asked to find each interior angle. So to find each interior angle, you're going to take the sum of your angles and divide it by the number of sides you have. So if we take that 1,260 degrees and divide it by 9 sides, right? Because we have 9 sides, then what you're going to do, what you'll get is 140 degrees for each angle. So each interior angle has a measurement of 140 degrees for a regular nonagon. Then we're being asked to find the measure of each exterior angle. Well, we know with any shape, any polygon, the exterior angle, it's like if you take each side, you draw a line out, right? Let me just draw a triangle real quick. If I take a triangle, I have an interior angle here, I draw the line out here, I got my exterior angle. Well, the interior angle plus the exterior angles, they're always supplementary and equal 180, right? To find an exterior angle, that's simply going to be equal to 180 degrees minus the measure of one of your interior angles, which would be 140 degrees. Which then means that one of your exterior angles would simply equal 40 degrees. So in a nonagon, a 9-sided figure, each interior angle equals 140 degrees in a regular nonagon, and each exterior angle equals 40 degrees in a regular nonagon. And that makes sense. 40 times 9 would equal 360. So there is that one. We have another exercise like it. I'm going to keep the formula up here because that's a very important formula. What if we have this time, alright, we have a 15-gon. We got to figure this out for a 15-gon. It's, other words, 15 sides, right? So let's see, let's look at the interior angles. The interior angles would be then, the sum of the interior angles is going to be equal to that 15 minus 2 times 180 degrees, which then of course would turn into 13 times 180 degrees, which then is going to equal, well, let's figure out what 13 times 180 is. I don't know that off the top of my head, but I can sure find out. 13 times 180, that's 2,340 degrees, or 2,340 degrees. So the sum of the total measure of the interior angles of a 15-gon is 2,340 degrees. Now I'm going to take that total sum, that 2,340 degrees, and I'm going to divide that by the number of sides that this polygon has, which is 15. So take your 2,340 degrees, divide that by 15. Let's see what we come up with. And each angle would equal 156 degrees for each interior angle is 156 degrees. Okay. Well, what this is now, what I want to tell you though is, so when you find the sum of the measures of the interior angles of your polygon, to find each individual interior angle, you take the sum of those measures, divide it by the number of sides you have, and then you'll come up with the measure of each interior angle. Now to find the exterior angle, let's find the measure of one exterior angle of a regular 15-gon. You're just going to take 180 degrees minus 156 degrees, which would simply equal 24 degrees. So the measure of each exterior angle of a regular 15-gon is going to be 24 degrees. So that's really not too bad either. Alright, what's the next one? I have 5 more left. Okay, so what about a 30-gon? This is a 30-gon. So that tells us here we have 30 sides. So let's start with the sum of our interior angles. Let's start there first. Well, we have 30 sides, so it's going to be the quantity of 30 minus 2 times 180 degrees, which would turn into 28 times 180 degrees, which that's going to give us a big sum. That'll be huge. What is 28 times 180? That's 5,040. So the sum of your interior angles of a regular 30-gon is 5,040 degrees. Now we want to find each interior angle. So each interior angle is equal to that 5,040, that sum, divided by the number of sides you had, which was 30. So let's take 5040, divide that by 30. You get 168 degrees. So the measure of each interior angle of a regular 30gon is 168 degrees. Which now for each exterior angle, this is pretty easy. That's going to be equal to, of course, 180 degrees minus that 168, which means each exterior angle is only 12 degrees. So each exterior angle of a regular 30gon is going to be 12 degrees. Now this is going to change a little bit for the next 4 problems. This time we don't know the number of sides. We got to figure out how many sides a polygon has, but what information do they give us? Let's see, the measure of each exterior angle equals 6 degrees. All we're given for this one is the measure of each exterior angle equals 6 degrees, right? What do we do if we're only given the exterior angle? So how in the heck are we going to solve that? Well, what you got to do first, I would say find your sides. Start with the easiest thing. We know the sum of the exterior angles is going to be 360, is it not? So how many times do we got to multiply 6 to get 360? Okay, so let's take that 360 degrees and divide that by 6 degrees. So what you're going to do to figure out your number of sides, here, let me write this a little bit better, teach it a little bit better. To get the number of sides of the polygon, you're going to take your 360 degrees, which is the sum of your exterior angles. You're going to divide that by the measure of each interior angle, which is 6 degrees, which should simply give you 60 because the degrees will cancel out. Since you're dividing both units, the degrees will cancel out. So this is a 60gon. You have 60 sides. So that's a big figure. Now, good news is, if you're asked then to find the measure of each interior angle, in this case it's actually a lot easier than the first 3 problems. You know how? Because an interior angle and an exterior angle are always supplementary. They always add up to 180. So if you want to find the individual measure of a single interior angle of a regular 60gon, you're going to take that 180 degrees minus the measure of a single exterior angle of that 60gon, which would just be 6 degrees, which means the measure of a single interior angle of a 60gon would be 174 degrees. Just for one angle of a 60gon, you would get 174 degrees. And I got another problem like this. And then the last 2 will change yet again. Okay. What do they tell us here? Well, let's see. The measure of each exterior angle is 8 degrees. Alright, so this time we know that the measure of a single exterior angle of this regular polygon is 8 degrees. We still don't know how many sides it has. Well, that's easy enough to figure out. All you're going to have to do is to find the number of sides for this. Is you're going to take the total sum of the measure of the exterior angles, which would be 360 degrees. You'll divide that by the measure of a single exterior angle, which is 8 degrees. And then you should get your answer for the number of sides. So what is 360 divided by 8? It's 45. So this particular polygon has 45 sides. So we're dealing with a regular 45-gon. Alright, well that wasn't so bad. Now we need to find the measure of each interior angle. The measure of each interior angle doesn't require this fancy formula in this case. All that requires you to take is 180 degrees minus the measure of one exterior angle, which would be 8 degrees, and you get the measure of a single interior angle of a regular 45-gon would be 172 degrees. So now, given this information, we've answered how many sides the polygon has. We've even answered how many degrees a single interior angle of this polygon has. So that's not so bad. Now the last two problems are different yet. They're going to switch up what information they give us to start. What they give us here in this one is the measure of each interior angle is 165 degrees. Alright, so the measure of each interior angle is 165 degrees. So, when you're only given the interior angle, you still have to figure out A, how many sides does this polygon have, because we don't know yet. B, what is the measure of each exterior angle? Well, it's actually pretty easy to go first for each exterior angle. So, let's look at the measure of each exterior angle. Let's go for that first. Well, we know the interior angle and the exterior angle, again, they're supplementary angles. So all you have to do is to find the measure of a single exterior angle is 180 degrees minus the 165 degrees. And then you get the measure of an exterior angle being 15 degrees. So for this polygon, however many sides it has, the measure of each exterior angle is going to be 15 degrees. Now, last but not least, we just got to figure out the number of sides it has. Well, this is why I had us start with a measure of each exterior angle, because from here, it'll just be like the last two problems. We can just go on and find our sides. All we have to do, once again, to find the number of sides of this regular polygon, whatever it is you'll take your 360 degrees, which are the sum of the exterior angles of the polygon, divide that by each exterior angle, which is 15 degrees. Now it's just a simple division problem. What's 360 divided by 15? What? Okay, good. 360 divided by 15, 24. So this particular regular polygon has 24 sides. So it's a 24-gon. And I got one more problem like it, and that's actually the last problem for this lesson. Alright, so what do they give us in this particular one? They give us that the measure of each interior angle is 178 degrees. So the given information we have is the measure of each interior angle is 178 degrees. We still have to find how many sides does this polygon have. We have no idea how many sides it has. We also still don't know yet the exterior angle measurements of what each exterior angle is, but that's going to be easy. Let's start with the measure of each exterior angle first. The measure of each exterior angle, to find that, again, an exterior angle and interior angle are supplementary, so you'll just take 180 degrees minus the measure of one of your interior angles. So it's 180 minus 178, which gives you 2 degrees. So the measure of each exterior angle is only 2 degrees. So we've figured out our exterior angles. Now from here we can find our number of sides. Number of sides is going to be easy. You just take the sum of the measure of the exterior angles, which would be 360 degrees, divide that by each exterior angle individually, which would be 2 degrees. Well, 360 divided by 2, that's 180. So this regular polygon has 180 sides. It's 180gon, which I can't even imagine what that looks like. That would give me a headache even trying to draw that. So I also want to point out, we could have, to find the sides, we could have gone through this formula and done a bunch of algebra. I don't see a need for that. I don't see a need to make our lives harder when there's a much easier method to do it. I believe there's a time and place for algebra, but I also believe there's a time and place for practicality, and to get the same result much faster. Well, so that's why we did it the way we did it today. So let me recap. First, if you're given the number of sides of a polygon, you want to start out then, once you've been given the number of sides, by finding the total measure of the interior angle, the sum of the total measure of the interior angles of that polygon. And then to get each individual interior angle, you're going to take that sum that you got, divide it by the number of sides, and then you'll come up with the measure of each interior angle. And then to find your exterior angle, remember that interior angles and exterior angles are always supplementary, so just take 180 minus your interior angle, you got the measure of your exterior angle. Next, if you're only given each exterior angle, if that's all they give you, the measure of a single exterior angle, then what you need to do first, well, you can do it either way. I suppose it would have been easier first to find the measure of each interior angle, so just take 180 minus the measure of the exterior angle, you have the measure of each interior angle. And then to find the number of sides the polygon has, you just take that 360 degrees divided by each exterior angle, you'll get the number of sides the polygon has. And then these last couple problems, if they only give you the measure of each interior angle, they don't give you anything else, start with finding your exterior angle. So take 180 minus your interior angle, you'll get your exterior angle. And then to find the number of sides, you just take 360 divided by the measure of each exterior angle, and you'll get your number of sides, which in this case is 180. So that's really it for this lesson. Next lesson we are going to talk about deductive reasoning versus inductive reasoning. So I hope everyone has a good night. Take care.